Alright, so let's get started. So what I have here is an index.html file, and it has a canvas element which is used to draw shapes, and then I have included the app.js file as a reference here in this HTML and some styling for my canvas element. Now let's go to the app.js file and let's have a reference of canvas element within this JavaScript file here. So I'll say var canvas is equal to document.get element by id canvas, and now we can assign the width and the height to this canvas element. So I'll say canvas dot width is equal to window dot width, or maybe a smaller, let's have a smaller canvas element, let's say 400, and canvas dot height is equal to 400. And to draw anything on this canvas, you need a context. So I'll say var c is equals canvas dot get context to d, and this context has various properties and methods to draw shapes and fill colors. So I'll say its fill style is black, and let's draw a rectangle, fill rect, starting from the 0 0, the top left of the canvas, spanning the entire width and the height. So I'll say canvas dot width and canvas dot height. And if I refresh the page, so I'll have a canvas here. So this is our night sky. I'm sure you're able to see this is a night sky, and this is our playground. So we would be doing the Starfield animation simulation within this canvas here. So first of all, let me create two functions. Let me define two functions: function draw and then function update. And from within this function, I would be calling window dot request animation frame method and a callback to the update function again. So this update function would be called on every tick of the animation, and let's call draw function from the update function, and our program would start from the update function. Oops, what I'm doing, right? And now let me take these two statements in the draw function here. So nothing would be new right now, but then we have the JavaScript structure for the animation loop. Now what we need is stars in the sky. So we've got the sky, so this is our sky. Now we need the stars in the sky. So first we need to display the stars in the sky. Then we need to have some algorithm to move through the sky, and so that it appears that all the stars are fanning out from the center of the canvas, and when the stars are reaching closer to the viewport or the or closer to the edges of the canvas, their size would get bigger and bigger, and the speed would also increase. Excuse me. So first of all, we need a star object. So I'll create a JavaScript constructor function star, and this star object would have few properties like a x value, a y value, and a z value. So x is for the x location within the canvas, y is for the y location, and z we would be using within our calculation to show the depth of the star, or the near, how far or near the star is from the viewport. And we would give them a random value. So I'll say math.floor math. Let's not use math.floor, because when we would be using the math, the calculation, we would have some floating variables, floating values. So I'll say math.random into canvas.width, math.random into canvas.height, and I'll say math.random times canvas.width. So now we've got the three properties of this star objects: the x, y, and the z. So this is width, right? And now we're gonna create how many stars we need in a sky. Let's give it a variable num stars let's say we'll start with the 100 stars, and we need a way, we need an array to store all the objects of the star function or the star object, all the instances of the star object. So I'll say var stars empty array, and I'll loop through var I is equal to 0, I is less than num stars, I plus plus, and each index of the stars array here would contain a new star object. So now we've created 100 stars, and now we want to show these stars on our canvas. So within this star constructor function, I'll create a new function called show, and we would want to display these stars as a circle on our context on our canvas. So I'll say c dot begin path. It's a context method to draw shapes, and c dot arc is used to draw a complete circle or a part of the circle. So starting from the x and the y location, giving it a radius or a size, the radius of the circle, and starting from the 0 angle to the math.pi, which literally means 360 degrees. So if you want to create a complete circle, start from the 0 to the 360 degree. And this size is not defined here, not declared here. So I'll say var size is equal to 1, the radius of this circle, or the radius of the star. Now we'll call this function. So let me copy this loop here. 1,010 times I have written this loop. So let me call this function show from the draw function, and on refreshing we would be able to show. No, it's not working. So I was expecting that stars would appear in the sky. Let me press F12 to see if there's some error. There is no error. So we've missed something. So stars.show. Oops, classic. First of all, we need to have a fill style of white, and we need to call c.fill. And then yes, now we are able to see stars in the sky. But each star also has a random x and the y value, but every star has the same size, and it doesn't give a look of a 3D sky. So we want the stars which are further from us, further from the viewport, should be smaller in size, and which are closer to us should be larger in size. So for this we need to do some maths, and so we need to, so within the show function, here we'll do some maths here. So there is an algorithm which I've searched on the internet. So I'll create 3 variables, x, y for the x and the y location, and then the s for the size of the star. So as we've discussed that the star which is further from us should be smaller in the size, so giving us a feel of a depth within the sky, and nearer to us should be larger in the size. And then so let me create few variables here globally. So let's say FL for the focal length, the entire I would say the size of the sky, or in this case the canvas. So I'll say canvas dot width. Then the center of the x-axis and the center of the y-axis. So var center x is equal to canvas dot width divided by 2, and var center y is equal to canvas dot height divided by 2. So we'll now do some maths here. So I'll say x is equal to this dot x minus center x times focal length divided by this dot z, and x is equal to x plus center x. Same thing for the y value of this star. So y is equal to this dot y minus center y times focal length divided by this dot z, and y is equal to y plus center y. Let's save this. Let's run this. No, not change. So, oops, we've not changed the size. So let's say S is equal to size times focal length divided by this dot z. And so let me change here also. So this now should be X, Y, and S. All the stars are gone. Oh well. So it should, the further this star, the smaller is the size. The further the star, the smaller is the size. So am I calling this dot show correctly? Okay, so the further the star, so I think this, we need to do something here. This size times focal length. Start show. We have the canvas width, which is set to the focal length. I'll take a second here just to debug this. Oops. I guess only the spelling mistake here. Yes. So this formula was correct. This formula was correct. But I had used a typo. There were some typos. So now, as you can see on this guy here, so it now giving us a look of a 3D sky. So the star which is further is smaller in this size. The star which is nearer to us is larger in the sky. Now, so we got the different sizes as per the z value of the star. But now we want to move these stars in the sky. So I want to visualize this like if we are if you are in a spaceship, you are moving in the sky, moving through the sky. There are stars all around. So when you're moving at the speed of the light divided by 1,000, whatever, when you're moving at very fastly, as soon as you would approach a star, its size would grow in size, right? The star would remain the same, but of course, when the objects are nearer, they look bigger. And you would want all the stars to fan out from the center, right? Go from your top, go from your left, go from your right without hitting you. So what we need to do is that we need to update the value of z. So I'll say within this, I'll say this dot move is equal to function, and on every tick of the animation, let's update the value of z. This dot z is equal to this dot z plus 1 minus 1, and if this dot z is less than or equal to 0, then reset the value of the z to again canvas dot width. No. So let me call this. So I have not called this function. So let's say stars index I dot move, and now yes, so now we've got the Starfield simulation, and in a way this project is over. So as you can see, all the stars are fanning out from the center, and when they are approaching us, when we are approaching the star, their size is increasing, right? And on every tick of the animation. So this is 3D animation by using HTML5 and JavaScript. Very simple. Now what you can do is you can actually increase the speed of the stars also, the movement of the stars, the speed of the stars, you can increase that. So instead of so let us create a variable, a global variable. Let's call it speed. Var speed is equal to 1 right now, and here in the move function let's say speed instead of hard coding. So this is right now 1. Now if I increase the speed to, let's say, 10, okay, so the no, it's not working. The size is increasing. The size is increasing. Oh, oh, sorry. It should be here. Silly error. And now we would be able to see stars moving at a much faster speed. So I hope you like this tutorial. There are a few enhancements to this project that you can do at your end, and please share the link to the code that you develop on this little tutorial here. Maybe you can start this animation only when your mouse enters this canvas, and you can control the speed of the stars on a mouse move event in JavaScript. So if you move the mouse towards the left, the speed of the star decreases, and if you move the mouse towards the right, the speed of the star increases, and many other additions that you would want to do yourself. So whatever you do on this little tutorial, please share it with me. Ask questions, share some comments. Thank you so much. Subscribe and like this video, because every week I'm gonna upload new tutorials. Stay in touch. Thank you so much.